All right, so we were over here somewhere. So the previous one was about measures of center. Now they talk about measures of dispersion. So dispersion just means, like how much sort of variation there is occurring in the data set. So sometimes people say variation, sometimes people say dispersion, sometimes people say measure of spread. All right. So like, for instance, if I gave you a bunch of numbers here like this, and let's say these two number lines were drawn to the same scale, and then I gave you some other numbers over here, like this one seems like it's varying more than this one. Is that correct? Does that make sense? We need a way to characterize this. So then because let's say you have like a factory and it keeps making like Coke cans over and over and over again. So it's got to fill up like the 12 ounces each time, right? Well, like it sort of matters how much on average it's going to fill up the thing with, right? That matters a lot. Is that correct? Because you wouldn't want there to be like 4 ounces in the can and there was supposed to be 12, right? But it also matters how much variation it's filling it all up with. Because for instance, let's say the first one it fills up correctly, it fills it up to 12. Next one it puts 16 ounces, and the next one it puts 8 ounces. Well, the 8 ounces is missing a lot. The 16 ounces is going to spill all over the floor, right? So the amount of variation that's in the process like that also matters, right? So you want the average to be correct, but you also want the variation to be small. Does that make sense? All right. So we need some way to start saying like what the variation would be, etc. No. Come on. All righty. Sorry about the delays so far. Okay, so like maybe here's another example that I think like you'll understand why you care about this, right? So let's say you're going to a job, right? You get this job and they start talking about, you're going to make money based off how much stuff you sell, right? And you go in there and they're like, let's say he works there. I go ask him, I'm like, what would be I watched this thing a couple of days ago and it said like, it was on Instagram and it was like, it said, if you're African-American and you go to get a job, what are the questions that you'll typically ask, right? I'm talking about you're the employee, you go to the job, right? You don't ask the boss if you've ever been in jail before. So like well, they always ask every employee you've been in jail before. It doesn't matter black, white, or green. But well, they're supposed to. But the thing is like, so let's say you're the employee, you're looking for a job, right? And you're getting hired at some place, right? And they were like, well, what do you ask about, right? And like they brought this guy in there, and the first thing he's asking about was like, well, how much money am I gonna make, right? That's the first question. Second question was like, do you get paid on time, right? On time. I mean, that's pretty reasonable question to ask, right? Like stuff like this, right? But the thing is like if you're doing a sales type job and you're getting paid based off commission or based off how many times you sell something, well, like you don't know how much you're gonna sell tomorrow, right? Maybe tomorrow you don't sell that much and the next day you sell a lot or something like that. Then you wouldn't make the same amount each day. Is that correct? Right? So then the first thing you would naturally go and ask in that type of situation is yo, about how much money you make in a week, right? Right? Because if you're not making that much money a week, and like 1 week you're making like 10 grand, the other week you're making like $5, like I got some problems. You know what I mean? I'm not gonna be able to pay my rent, right? So like the and whatever else, right? So like the so maybe when you go there, right? Because like I mean, these people aren't statisticians. They're just gonna be like, probably selling something over the phone, right? Whatever it is. And they, you don't really know what the deal is here. Like you don't know how much money you're gonna make. Is that correct? So then maybe you would come up with this idea. Maybe you would sit there and you calculate this range thing, which is like the largest value minus the smallest value. Why would you do this? Well, if I sat there and I was like, how many things am I going to sell a day? Let's say today I sell 1, tomorrow I sell 10, the next day I sell 2, the next day I sell 3, the next day I sell 2, something like that. Does that make sense? If you take the largest amount minus the smallest amount, it would tell us something about how much this is varying. Is that correct? Does that make sense? Why is that not a good way to do it, though? If I just take the largest number minus the smallest number. I don't like the way you're saying it, but the beginning part you said was correct. You don't know like how often, let's say you're getting 10. Is that correct? Or vice versa, how often you're getting 1. Does that make sense? Right? If I'm getting 1 like 75 times and I get 10 once, I don't know if I really care that I got 10. Does everybody understand what I'm saying? Most of the time I'm just selling 1. Is that right? Does everybody understand what I mean with that? All right, here's another way we could say it. Like, let's say we talked about the wealth distribution of the United States of America. So there's somebody out there with 0 for sure, right? And then there's someone out there with like billions and billions of dollars, right? Hundreds of billions of dollars. Is that correct? But most of the people are down here. And there's like a few people over here. Does that make sense? Right? But if I do the range would be this value minus this value, and then we would get like 100 billion. Or more, actually. I think Elon Musk has like 200 billion. But we get something like this. Does that make sense? But most of the data is not actually varying over this entire range. Most of the data is varying over that range. Does that make sense what I'm saying? Right? What's the point of taking this biggest number over here and subtracting it? This biggest number over here, we generally refer to that as an outlier. It's a number that's not really representative of the rest of the data set. Does that make sense? So lots of data sets will start looking like something like this. Where most of these numbers are actually falling like right there. Does that make sense? I don't see the point of doing this number minus this number if we know most of the numbers are over here. I should probably do that number minus that number. Is that correct? We don't know where those are. We don't know what that is necessarily. Does that make sense what I'm saying? We just have data, okay? But you see how the range could be a little bit of an issue. Does that make sense? All right, but you still need to know what range means. You still need to be able to say it's the largest value minus the smallest value. All right, so now they start talking about standard deviation. The standard deviation is a sort of average of the amount of which items in a distribution differ from their mean. The standard deviation is a measure of how clustered the data set is to the mean. If the standard deviation is relatively small, the data set is clustered together. If the standard deviation is large, the data set's more spread out. The symbol for standard deviation is S. The symbol for sample standard deviation is S. The symbol for population standard deviation is sigma. And then the formula changes slightly. We divide by n then, all right? We don't really talk about this in this class that much, but you do talk about it in SBA 2023, so I'm just mentioning it. All right? Most of the time, I would say people have no idea what this formula means at all. All right? It's pretty complicated, honestly. Does everybody see that? All right. So we got to do some examples to make sure that we understand what this formula is, what it's calculating, all that kind of stuff. The 2 examples I'm about to give you, they're going to work out very nicely. They're going to be easy. And you're actually going to be able to guess the correct answer before we start. Okay? But it's not usually going to work like that. All right? This formula has a square root at the end. We know if we take square roots of numbers that are not perfect squares, like square root of 9 is 3, but square root of 7 is like, I don't know, it's got like lots of decimals, it never ends. Does that make sense? So you get like weird looking numbers. Do you understand what I'm saying? Most of the time, okay? But I'm picking the numbers that I'm doing right here intentionally so that we will end up getting something that's nice. All right. So first data set, let's just say it's 90, 100, 110. Okay. Second data set, let's say it's 99, 100, 101. Just going to write the formula here again, just so we have it. So that's S is equal to the square root of the sum from I equals 1 to n of xi minus x bar squared all over n minus 1. Let's just see if we remember, what does x bar mean again? What does x bar mean? Because they say x bar is in the formula, so if we don't know what that is, it's going to be pretty hard to do the formula. What does x bar mean? Come on, look it up. So what does it mean? It means the average. Is that correct? Don't you remember x bar means average? Is that right? Okay. So this means the average. What's the average of the first one? What's the average of the second one? 100. These two things have the same averages. Is that correct? Which one has more variation? First one. Does that make sense? If you had to guess a number that you said was the variation, what would you guess for the first one? What would you guess for the second one? First of all, this number minus this number is 2, not 3. This number minus this number is 20, not 30. But no. If we had to guess a number that this one was spread out by and this one was spread out by, how spread out would you say they are? What's the first one? What would the last one be? You're guessing, so you just say a number. There's no thinking here. You just speak. I would guess 10 and 1. And guess what? That's the correct answers. All right. But I don't know what you guys are so scared to say anything for. Like, if I say guess a number, right? You don't know the answer, obviously, then. Is that correct? Right? But I'm pretty sure, I'm just pretty sure actually. I guess every time I ask this question, people seem to be able to tell me the correct answer. So these are these two data sets. The average of this one is here, and the average of that one is there. Any question? What does deviation mean in English? Off track, that would be something usually something like deviate, something like that, right? What would a deviation be when we talk about numbers? That's true. So like, but there's a specific thing we can say, like what a deviation actually means. If I just say, oh, a deviation, what would that be? Give me an example. I know you know what these words mean. Okay, but that's not a deviation. A deviation doesn't mean something that changes, right?
So like you have a set pattern, like it was set pattern like 5, 10, 15, 20. And then 5, 10, 15, 5, 10, 15, 20. Then next one is 40.
It's 40?
Yeah.
Yeah.
40, 60, 80. I mean, it's random. It has a pattern. If it has a pattern, and then it deviates like it.
Okay, but you're saying deviates. That's correct. You're deviating from the pattern. That's correct. But I'm asking you, what is a deviation? So what would the deviation be? Again, this is just English. It's not math. Because all I'm asking you is, you just told me the verb, what the verb means, right? All I'm asking you is what happens when that word's like ION now, right? Now it becomes a noun. Does that make sense? But what does that noun mean? No, I want an example with numbers. I want you to say the words with numbers, and I want you to tell me what the deviation would be. So give me a situation, use the word deviation in the sentence, and then tell me what the actual deviation would be, the value. Because I mean, if you don't know what the word means in English, how am I going to explain to you what it means in math? Right? And I know you know what it means. So let's go. Come on. Use a word in a sentence. Do it. You guys are like bumps on a log today. What? It's not funny though. Like, I know you know what this stuff means. Like, you can't. Okay. I say this to people all the time. I have not met very many stupid people in my whole life. I'm serious. I'm really serious. Like, I have not met too many people in my life who I can legitimately turn around and be like, yo, that person's brain just don't work like everybody else's. You know what I mean? They're stupid. You know what I mean? Like, honestly, it's very hard for me to even think of one person like this. Honestly. Does that make sense what I'm saying? But I have met a shitload of people. Like almost everybody, actually. Let's say everybody. Every single person I have ever met in my entire life. Okay. This one the person likes, this one the person doesn't like. Whatever those two things are. You know what I mean? And then the one that the person likes, they go and do it. The one that the person doesn't like, they don't do it as often. Right? But when you don't do it as often, the first time, the second time, the third time, the 15th time, then all of a sudden, that person gets put into a situation somewhere later, and they start being asked a question, and all of a sudden they turn around, they start giving me these eyes like this. Or they just kind of like fake. You know, like you ask them a question. You know what I'm saying? Now, is the person stupid? No.
This makes
No, they have, but the thing, now I'm not talking about shyness. I'm not talking about shyness. Because I have never met a person who's shy enough that when you keep asking and asking and asking and asking and asking and they know the answer, that they won't eventually answer because they just get bored of hearing about it. They don't want to hear you keep saying this over and over and over and over again. You get what I'm saying? They eventually just say it. Like I have people who are so shy, you have no idea. Like you have never met. Like these people have literally personality disorders. How shy they are. You get what I'm saying? All right. Anxiety disorder, social anxiety disorder. Right. Now, what I'm trying to say though is, if you don't try with things and you wait for people to tell you the answer, you can't think. Because then what happens next time is you get put in some other situation and now all of a sudden people are expecting you to think for whatever reason, whether you can or you can't in that situation, whether you have what you need to know or you don't have what you need to know beforehand. But people will ask you to do it in that situation. And all of a sudden, the people who sat there all the times beforehand and they just tried, they might be stupid, but they tried, they'll go and they'll be able to do it. The people who didn't try all those other times, and they might not be stupid at all, will not try. They'll wait for someone to give them the answer. Does that make sense what I'm saying? You do that too much, other people will call you stupid. Do you understand what I'm saying by that? Everybody can always do it right at the beginning. Everybody. I've never met a single person that can't do it. I met a lot of people that don't do their homework. I met a lot of people that don't like stuff and don't keep up with it, right? And then I do not call these people stupid because I can see them do all kinds of different things. But eventually the person can't do anymore because of how many times they've taught themselves not to think about it. Does that make sense what I'm saying? But at the same time, right? There's so many times where I've sat there and I've refused to learn. They tell me do it this way. I don't listen. Do it the wrong way. Cause myself all these problems, all kinds of things, right? But there have been times in my life where I sat there and I have done the wrong thing, 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 quit, got smacked in the face, finally decided to go and do it later on. And then I did it the right way that time and it didn't make any difference that I skipped all those years, the 20 odd years of doing things the wrong way. Does that make sense? Do you get what I mean by that? But you can either be column A or column B. You can either be the person that waits or the person that doesn't. Does everyone understand what I'm saying? And that's your choice, honestly. No one can force you or whatever. You know what I mean? And honestly, you could even have someone who's the best in the world sitting and explaining to you and they're a parent, they're forcing you to do this and blah, 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 blah. Well, one day you're going to have to do it by yourself again. And it don't matter what mommy and daddy did. Does that make sense? To some degree. All right? It does matter what mommy and daddy did. But does everyone understand? All right. So no one cares if you get something wrong. No one cares. Does everyone understand what I'm saying? But I will fire people over and over and over again for not trying. When I was at work. Fire people all day long. Swear to God. Because I get bent out, I get fed up. I just sit there. I remember I was running this business. We had all these drug addicts we used to hire, and we used to bring them into the business and stuff like that. And these people would come in there and they would be doing what they're supposed to be doing. This one's doing what they're supposed to be doing. This one's doing what they're supposed to be doing. That one's going off and smoking whatever every 5 minutes when they go on their little breaks and whatever the hell they're doing. All right. Over and over and over and over again, we're hiring all these people, right? So this other guy was running the business first. He ran out of money. So he asked me to borrow money from me. I stole the whole business from him. Bought the whole damn business for $10,000. Swear to God. 15 employees. Bought the whole damn thing because he didn't have a dime. Place would have closed that day otherwise. All right. So I go in there and these people are working and they're doing all this nonsense. And, you know, I'm like, why are you wasting your time with this crap? You know, like all these random things. And he tells me there's going to be some new hires. They're hiring some employees. We do it every Monday because there's so many people that end up leaving by the end of the week. You have to hire new people every Monday and they're going to sell stuff. Okay. So Monday, I come in there. These people are there. They're like, these are the new employees. There was a girl, these two guys. One dude was fairly old. The guy was, I looked at him and I was like, yo, that looks like a complete dirtbag. Like, what that, how do you come dressed up like this to your first day of work, right? And the girl seemed completely normal and fine. So they're like, you go in there and start talking to them about some stuff, you know? I was like, me? I was like, I've barely even been here. I said, what do you want me to do, right? But whatever, I'll go talk to them. I don't care. So I start talking to these people. I don't remember what the guy said. The old guy was there. I was like, forget it. We should have hired him. Get rid of him. He's not gonna be able to use a computer. It's not the right job for him. He's just gonna waste this guy's time, honestly. We're gonna have to fire him in a week or two anyway. Like, do him. Don't lie to him. You know what I mean? Don't take him. Okay. There was another guy there. I was like, forget it. I was like, this guy doesn't even need to fill out the application. Don't even give him the paperwork. Don't bother. Hire the girl. Put her in. Let's get her going right now. And then he's like, you did all this in 3 minutes. You didn't even speak to them. You didn't even ask them anything. How do you know who these people are? I'm like, I don't. But the old guy said he doesn't know how to use computers. The guy in the middle said something dumb. And I can't remember what the guy said, but he said something that I was like, that guy should not be in our office. All right. So then they told the rest of these people went in there. And they hired all 3 of them. All right. So like, we need the employees. We don't have the employees. We don't have enough employees. We're going to close. We need the employees today. I was like, you don't need garbage. You need employees, but you don't need garbage. You're going to end up working more for these people than they're going to make you. There's no point. Take the girl, make her do well, forget the rest of them. Okay? So the 2 people I remember who ended up working there for a month. The 2 people I said not to work there. They're working there for a month. They didn't make a dime. A dime. Okay? We ended up getting charged for these people because they were too stupid. They did something wrong. And then I remember one of this, we used to transport these cars. Cars flipped over. They didn't follow through with it. We ended up getting charged for something we shouldn't have gotten charged for. Okay? So not only do you have to waste time training these people, not only do I have to waste time listening to them, not only do I have to waste time, all these things, but it costs money too. Eventually, someone will turn around and be like, forget it, move on to the next one. Does that make sense? I'm telling you, you can't let people think like that. Does that make sense what I'm saying? Even if you go and start telling someone you don't know how to do it, but you're trying, you'd be surprised how far that will go. Does that make sense? You'd really be surprised. I don't remember a single place I ever got fired for saying I don't know how to do something. that understand? I remember a bunch of times though, where I got in some serious shit because I either misrepresented myself, because I tried to make myself look better when I didn't, when I knew I wasn't really doing what I was supposed to be doing. You know what I mean? Or just didn't try at all and then waited. And something bad ended up happening and then they came back to me. You get what I'm saying? Okay? You're not stupid. Does everyone understand what I'm saying? Unless you let yourself. Does everyone understand? You're not. I'm telling you the truth. Okay? But when I ask certain questions and I see people just like this, like that, with the eyes. Sorry, I didn't do the eyes at the same time. Like that. But when I see people doing that sometimes, and I'm like, you know, I mean, don't get me wrong, this shit's annoying. It's not the easiest. I'm not gonna say that, okay? But the thing is doesn't matter. If you're at I, you need to go, it goes to J. Is that correct? Do you understand what I'm saying? It's always gonna be a problem eventually. There's always gonna be a place that everybody has difficulty, okay? The difference between you and that other person is you gonna try. Does that make sense? That's it. Nobody else can ask for anything else. Okay? All right? So if you don't know, so what? Don't be insecure. Does that make sense what I'm saying? Because it makes people do, makes you look worse than what you'll ever be. Does that make sense? Okay? And then of course, I'm the other side of the coin. I'm the person who's too secure with a lot of these things. So I'll do it the wrong way because I'll just be like, oh, I know how to do it. That's a problem too. Does that make sense? You got to be in the middle somewhere, right? Okay. All right, anyway. So the answer to the first one's going to be S is equal to 10. The answer to the second one's going to be S is equal to 1. This entire thing that I'm writing out right now is just a little table to help us be able to organize our work so we can end up getting the answer, all right? This formula, all it says is the sum of all this stuff divided by n minus 1. And then I'm just going to call that part A. That part right there, I'm just calling it A. Does that make sense? What would n minus 1 be in the first case? What does n mean again? Number of things, which we referred to as a sample size previously. Now, I'm not expecting people to remember all of these words because you guys haven't gotten to it yet in your homeworks. Does that make sense? All right. But at the same time, some of them I am. Okay. Right. If we can just, so in other words, n minus 1. So what's n in this case? 3 is correct. So n minus 1 is 2. Is that right? So if I'm able to do A here, then all I'm going to do is divide that by 2 and then take the square root. Is that right? As long as I can figure out what A is, we're fine. Does that make sense? This entire table I'm about to write out is just to figure out what A is. All right. Xi just means list out your X's. So I'm just going to call this one X1, this one X2, and this one X3. So X1 is 90, X2 is 100, X3 is 110. Does that make sense? By the way, I am not kidding about that confidence thing. I'm not about me. I'm talking about everybody else. Okay? Screw me. I don't care. I'm stupid. Doesn't matter what I do or don't do. Okay? And you're like, yeah, you're right. No, but seriously, it doesn't make any goddamn difference what the hell I do or don't do. Does that understand what I'm saying? It matters what you do. All right. And you tell me, you've seen people who are insecure in your life, right? You're a teacher, right? Right? You've seen this with students, right? Right? And you have students who there's nothing wrong with them at all. They're perfectly good, excellent people, honestly. But for some reason, the person gets it in their head, they can't do it. And what happens then? They don't try. Does everyone understand what I'm saying? They weren't stupid though. Okay? Anyway, we all do this to ourselves. Does everyone understand what I'm saying? We all got to think about this. All right? Always. It's not going to go away. You get older, you're going to have to think about it then too. All right? But it's important. Okay? Because mindset really does change what you're going to do. It really does change if you're going to try or not. Right? And that's all you can do. Right? All right. Anyway, sorry for the babbling. So these things here, right? Always what I'm going to write at the bottom is the sums. So if I add these things up here, what's the sum of the xi's in this case? What is that? 300 is correct. Then the thing is we should divide that by n to determine what x bar is. So I get 100. Does that make sense? Right. Now I need to do, this is what actually, what I was looking for when I was asking you, what is the deviation? All I wanted you to tell me was you need to subtract. Does that make sense? Right, you were giving me the answers before and you were saying what, 5, 10, 15, 20, right? The next one should be 25, right? Let's say it was 30, right? So what's the deviation? Well, 5 is correct. That's it. That's all I was looking for. Does that make sense what I'm saying? All right, this whole thing that we're talking about here is referred to as standard deviation. That's another reason why it's just helpful to know what the word deviation means. Does that make sense? All right, so now we're going to do this for this thing. X bar, we just figured out what that is. That's 100. Therefore, we would get negative 10. Is that correct? That's correct. The average in the first case was 100.
Oh.
Add up all these, you divide by 3, you get 100, right? All right, so we get negative 10. What does the negative 10 mean in the first one? No, it's just called deviation. But what does it mean? Explain to me in terms of the numbers. What does the negative 10 mean? $90 minus 100 gives you negative 10, right? So that means this thing is 10 units that way. Is that correct? Is that right? What's the deviation for the next number? What's the deviation for 100? Zero is correct. It'd be 100 minus 100. It's 0. Is that right? Why? 100 minus 100 is 0. Yeah, but why is the deviation for that term 0? Because it is the mean. Is that correct? How far is that number away from the mean? Well, it's not. Is that right? All right. What about the last one? What's the deviation? 10 is correct. 110 minus 100 gives you 10. Is that right? All right. What is the average deviation? What's the average of the deviations, or the average deviation from the mean, I should say? Nope, not 10. 0 is correct. How'd you get 0? Not what I want you to do. What's the average deviation? What does the average mean again? Right, so how many we got? 3. So we should add that up and divide by 3. Is that correct? So what is that? What happens when we add it up? 0 is correct. Minus 10 plus 0 plus 10 is 0. Is that right? Does that make sense? The sum of the deviations is 0. Does that make sense? So if I add this stuff up, the sum of xi minus x bar, we get 0. Is that right? This is always going to be 0 here. right? That's part of it. That's a definition of mean when you actually, right? The average position is the position that when you take the deviations from all the values, that the sum of the total deviations would give you 0, always. We can prove this if we have to, okay? So then what they say is that instead of doing deviations, we need to do something else. So if you look in this formula here, they square all of them. Why do they square all of them? Because then it'll make it positive. Then they're not going to be able to cancel anymore. Does that make sense? What's the first square deviation? What number do I put here? 100 is correct. This is the value we just calculated, right? Right? Now they're saying put that into the parentheses and square it. Is that correct? In other words, we would be doing 90 minus 100 squared, or we would do negative 10 squared, or we would get 100. Is that correct? What about the next one? 0. It's 0 units away from the center, so the square deviation is also 0. Is that right? What about the last one? 100 again. Is that correct? Therefore, the sum of the squared deviations from the mean, from I equals 1 to 3 or whatever, is equal to what? What is it equal to? Nope. 200. Because this, we just have to add up this number, and this number. Does that make sense? This is sum, just means add. Does that make sense? So this is going to be 200. Is that right? All right. So then the formula said S is going to equal to the square root of the sum from I equals 1 to 3 of xi minus x bar quantity squared, all divided by 3 minus 1, which is 2. Does that make sense? So then, well, we did the hard part, actually. The hard part is doing that numerator thing. That's just 200 now. 3 minus 1 is 2. This is easy now. What's the answer to this? 10 is correct. You get a square root of 100, and you get 10. And that was the same answer we said at the beginning. Does that make sense? Now, usually you just do this on your calculator. Does that understand? Okay. But I think it's helpful to write out the table to understand what I'm doing. Does that make sense? All right, now let's just, so sometimes people call this the root mean square, right? It's not exactly an average though, because the thing is we're dividing by n minus 1 here, not n. Does that make sense? Does that make sense? But it's almost like an average. We're taking the sum of all of the deviations. Saying like the first number has a square deviation, second number has a square deviation, third number has a square deviation. Then we're finding like the average sort of square deviation. Does that make sense? Then we're taking square root because everything was all squared. So we got to kind of bring it back to normal. Does that make sense what I'm saying? Right? You imagine like if these things were meters, 90 meters, 100 meters, 110 meters, then this number here would be something like meters squared. Does that make sense? If everything is meters, I don't want to do meters squared because I wouldn't understand like area. It doesn't really make any sense in this case. Does that understand? That's the only reason why we do the square root. Bring it back to like the same types of numbers we started with. Does that make sense? So you sort of find the average square deviation, and then after that, you take the square root of it. So it's sort of like the average deviation from the mean. Does that make sense? Does that make sense? Okay. How come you're what? Not even close. Not even close. Not even close. Standard deviation, I'm saying how spread out something is. Average, I'm saying where the center is. How do they mean the same thing? So you're saying because I calculate the average at some point somewhere, then everything becomes average? So what do you mean? How? Because of doing what? What do you mean? All we did was calculate averages last time, and this is a different calculation this time. I don't know what you mean. No, it does, because if you can say what you're talking about, I can fix it. Because the thing is that you're saying it's the same. I'm really just asking you what you mean is the same. If you tell me what you're thinking is the same, either then I'm going to be able to say, yeah, you're actually right, that is the same. Or I'm going to have to say, you know what? That's not the same thing, right? So when you say I mean, we know that the formula for average is this. These two are not the same for sure. Does that make sense? Okay, but whatever, those are just symbols, right? So think about what you're saying and then tell me when you get a chance, all right? Let's just do one more example. This time I'm going to skip this middle step here. The reason why I'm going to skip this middle step here is because it's not exactly very helpful. We're going to get 0 every time. Does that make sense? So also, you know, this was the deviation for that value. This was the deviation for that value. And then deviation for this one was like 0. Is that correct? It should make sense in terms of the picture. You understand? All right. So now what are we going to get? What's the first square deviation here for 90? Oh, excuse me. I'm sorry. What do I do first here? Well, we know it's 100, but first we should get 100 first. Okay. So the sum of the x's is what? 300. So x bar is 100. What were you going to say now? Sorry. But then squared. Does that make sense? All right. So what is that? 1 is correct. What's the next one? Zero is correct. What's the next one? 1 is correct. What's the sum of the square deviations? 2. Does that make sense? What is the sample standard deviation equal to then? What do I write here? Square root of what? Nope. Sorry? 1 is the correct answer. So you get 2 over 2, then you get root 1, so you get 1. Does that make sense? And that was the answer we said at the beginning. Is that correct? So the idea with this thing is like if you have a data set, let's say this is the center right here. Then I'm going to find the deviation this thing is away. I'm going to find the deviation this thing is away. I'm going to find the deviation this thing is away. The deviation this one is away. The deviation this one is away. The deviation that one is away. The deviation that one is away. The deviation that one is away. Square all these numbers, then sort of like find the average of this and square root it. Does that make sense? It tells me how spread out things are approximately. Does that make sense? Do you understand? Yep.
What do you mean?
Where?
What do you mean by some square?
Square just means like, if you say like five square just means like 5 times 5. That's all I mean.
Oh, yeah.
I'm just saying, like, if you have xi, the formula says like this thing here. Right? First, you got to find the deviation, but then you got to square it. Does that make sense? Deviation just means subtract this minus the mean. Does that make sense?
But how you know that's me?
You have to find the mean first. That's why we did this part first, so you find the mean.
Uh,
You always have to find the mean first. All right, let's do this one. 2 brands of car batteries, each carrying 6-year warranties, were samples and tested under controlled conditions. 5 brand, whatever. Find the standard deviation for this stuff. I'll do the rest of it in a second, but let's first just do some examples where we calculate standard deviation. Does that understand? All right, so it's almost the same thing as what I just said in the last one. It's just now they've given us 5 numbers here. Does everybody see that? So I'm gonna write A first. I'm just gonna put them in order just because might as well have them in order. 65, 65, 69, 71, 72. Is that right? First step is add all these numbers up. Divide by 5. So we have, what's this? 13, 22. So this is 20, 34. I think it's 342. Good. 342 divided by 5. So what's that? 70, 68.2. Some number. Does that make sense? Question?
that's how many 5 divided by 3.
5 goes into 342, 68.2 times. So now we need to do AI. How did I do that in my head?
Yeah.
Because all I did was, I said that like, I can do 350 divided by 5. That's 70. Does that make sense? Then it's like, I was like, oh, I can do 340 divided by 5. That's 10 less. That has to be 68. Does that make sense? Then it's like, I'm wrong. Should have been 4 here. 68.4. I'm sorry. So then no, I said 2. I read 2 here and I read it wrong. So then the thing is this, right? This is like, if I have 341 over 5, it's 1/5 more. Does that make sense? It's 350 to 341. I mean, 340 to 341 is 1 more, right? Then if I do 342, it's 1 more 1/5. 1/5 is 0.2. 0.2 plus 0.2 is 0.4. Does that make sense? All right, so now we need to do this though. So then I would have to do 65 minus 68.4 squared. I'd have to do 65 minus 68.4 squared. 69 minus 68.4 squared. 71 minus 68.4 squared, and then 72 minus 68.4 squared. Does that make sense? And you got to do all these, all right? So this is what? 3.4 apart, so it's 3.4 squared. Does that make sense? We get 11.56. 3.6. 6 to the power of 4. 96. 1296. Yeah. Now I need to add up all these numbers, whatever these numbers are. I guess it's 39. Does that make sense? Yeah, definitely advise doing this in calculator. So then this S is gonna equal to the square root of the sum of xi minus x bar squared, all divided by n minus 1. What's n minus 1 in this case? This is almost 10. Does that make sense? The standard deviation for brand A. Does that make sense? Question with this? Do you understand or no? Literally just follow the pattern each time. It's just typing your things in your calculator. Does that understand what I'm saying? Question? So please try and write it out with the table. I find the table actually helps a bit. Okay? Yep.
You always been there?
My dad used to make me do it when I was a kid.
Yeah, I don't know.
Like my kid, like I forced him to do all this stuff.
Yeah, my
Like if there's no way he's not gonna be able to do it.
Only thing I know is that multiplication because when you get a composition book, all the multiplication is on it. You're using. What's 5 times time? What's 5 times 5? Smell my man, I don't know.
That's what
What's 10 times 10?
my dad, when I was in first grade, my dad went to work one day and he's like, I remember he went to work and he wrote the times tables on the board. No, he didn't write the times table on the board. He told me to write the times table. And I was like, I don't even know what this stuff is. And then he told me, he's like, he did a couple of them for me. And then I was like, oh, so it's like 3 times table just means you keep adding 3. The 4 times table just means you keep adding 4. I was like, I know how to add. I was like, I can do that part. You know what I mean? I'll just keep adding 3, keep adding 4, whatever. So I wrote out the whole table. And then he came home and I was like, I did it. I was like, it didn't take that long, honestly. He's like, because he told me it was gonna take the whole day for me to figure out, right? I was like, I didn't take that long. You know what I mean? It was like, all you do is just keep adding the numbers, right? Where he's like, yeah, you're right. He's like, but you don't know what this means. You don't know the answer. If I ask you one of the questions, you're not gonna know how to do it. So then he asked me one of them. And then I sat there and was like, oh, you said 7 times 6. Oh, okay. So 7 plus 7 is 14, plus 7 is 21, plus 7 is this, plus 7 is this. Right, and I just did it, and like that, but I just kept adding 7 over and over, right? So I got 42. And he's like, to this day, he still says it's the smartest thing I've ever done in my entire life.
Honest you, I would say I don't think I'll give my grandfather was it was my grandfather would know my 6 times table was by heart. I don't know why, but like 6 times table was simple. I don't know why. 6, 12, 18, 21, 30, 36, 42, 40, 42, 48, 54, 62, 60.
But the thing is like, if someone tells you these things are important, forces you to do them, you gonna do it. That's it. That's the difference. So I was forced to do this stuff when I was younger. That's all.
I mean, I wasn't like my aunt was born is good in the math. My
Well,
aunt,
this is the thing though, like, so people always, I remember when I first started teaching, like, I used to always tell people my dad's from India. They used to turn around to me and they used to be like, oh, well, you got that Indian brain. That's what they said to me. Well, let me tell you, I got a lot of cousins. They don't got that Indian brain. So and then I got some Jewish family I got. And they can do it. So it's like, and then there's some of them that can't do anything, you know? So my point is all these people grew up in the same houses and all that crap, right? The same parents, same everything, you know? Some of them just don't like it. Some of them do, right? But all I'm telling you is if you don't like it, it ends up costing your ass money. That's all I can say. All right, coefficient of variation. Coefficient of variation for a distribution expressed as the standard deviation is a percentage of the mean. So in this case, all you really need to do is just take the standard deviation and divide it by the mean value. This is really just a formula. So again, let's do it for one of these examples. Let's do it for example B this time. Because just like there was a formula for weighted mean, we can do something for weighted standard deviation also. So if S is going to equal to the square root of the sum of xi minus x bar squared all over n minus 1, this can also be rewritten as the sum of the frequency of how often those particular values occur, then the value minus the mean squared, then we subtract or we divide by the sum of the frequencies minus 1. I'm going to do it in that format because there's no point for me to take 10 and then subtract 4 times and get the same number each time. Does that make sense? I might as well just get it once and then multiply it by 4. Does that make sense? All right, so I'm going to write it in this format. I'm going to write the frequencies here now too. So we have what? 5 occurs once, 6 occurs once, 10 occurs 4 times. Is that correct? Now to find the average here, the thing is that this 10, I have to add it up 4 times. We can't forget to add it up 4 times. Does that make sense? There's 6 numbers. So the average is going to be equal to the sum of the x's times their frequencies divided by the sum of the frequencies. Sum of the x's times their frequencies, so that's 5 plus 6 plus 40 divided by 6. So that's 51 over 6. That's 17 over 2. That's what is that? 8.5. Oh, thank you. That could be an issue. So then this should be what, 11, 19, 59 over 7? Yeah. 59 over 7. Now this number is not going to work out so nicely. Does that make sense? So this is like
oh, that's a calculator?
Yep.
Oh, I don't know.
8.428517, I think, something like this. One, 4, 5, 1, 2, 3, 4, 5, 6. There should be a 1 second. I'm sorry. One, 4, 2, 8, 5, 7. 1. 4285714. 4285714. I'm stupid. Okay, whatever. That's right. All right, whatever. Something like this. Does that make sense? All right, but now we need to do what? Xi minus X bar squared. Does that make sense? So now for the first one, this is going to be quantity 5 minus 8.4285174 squared. So I get this number, 11.7547 approximately.
No, that was a 6, 7. Right. 7, 5, 4, 7, 8, 6, 1, 5.
1, yeah, 5 rounds to 1 up. I just rounded that number. All right. Then we need to do the next number. So this is going to be 6 minus 8.4285174 quantity squared. 5.2 something, right? But you gotta square it. 5.8976676. 5.897696676. Some number. Does that make sense? And that was for 6. Sorry. All right, now I gotta do 8. Eight minus 8.4285174 quantity squared. So this 0.183627, 0.183627, something like that. And then the last one, 10 minus. Now this is 8.4285174. Then we need to square this, right? So then we have this value here. Does everybody see that? So it's 2.469558. 2.469558. Does that make sense? Now we need to add up all these values and divide by, well, we got to be careful now. Because really, this number here is 10. This needs to be counted 4 times. Does that make sense? So you got to remember to do 4 times that number. Does that make sense? I mean, you don't have to. You can just do 10 4 times, but there's really no point. Does that make sense? So then we have this number now from before. I'm going to multiply this by 4. And then add the rest of these. So 0.183627 plus 5.8976966 plus 11.754732. We get this. Does that make sense? Does everybody see that? We have to divide that by n minus 1. What is n minus 1 in this case? What did you say, 3?
Oh, wait.
That's where n minus 1 is. Six is correct. How'd you get 6? That's right. So you just don't forget there's 4 of these guys, right? That's correct. So what, there's 7 of these things, minus 1 is 6. Is that correct? So then divide this by 6. Then we get that. Now we try to take the square root of this guy. So whatever the hell this stupid number is, we get approximately, I'll just round to something here. So I don't know, what does this say? 2.1492. 2.1492 approximately. Does that make sense? Now, if we want to determine what the coefficient of variation is, it's just the standard deviation divided by X bar. In other words, we have to take this number now and divide by that number. Does that make sense? Any question with that? I'm gonna explain in a second. So then this one, that, because honestly, on your test, they're not even gonna ask you. They're just gonna ask you to calculate it. That's why I'm like focusing on this, but I don't really like doing that. So, but all I would do is this divided by quantity, then it's 59 divided by 7. So we get this. It's about 25.5%,
You know, where it says my last day of school.
right?
You know, where it says my last day of school or no?
I'll put it online.
Oh,
So you get this. All right, what does this mean? This is a good question, what you're asking. Okay, so let me just calculate another one for you. But this time I'm going to do it on a like with a spreadsheet, okay? So I'm gonna give you two examples. These are really the same example, but we're gonna look at the numbers in two different ways. And all of a sudden, we're gonna get two different answers, of course. But there shouldn't be two different answers because it's the same stuff. But somehow this will fix it. Okay. So first I'm gonna list the numbers, then I'm gonna list the numbers minus the average, and then I'm gonna square them. Does that make sense? I'm gonna do this twice with two different data sets. All right, so let's pick some numbers. Let's say we talking about people's heights. Does that make sense? Let's say there was a 5 foot tall person, 6 foot tall person, 6 foot tall person, a 5 foot tall person, 7 foot tall person, 5 foot tall person, 6 foot tall person, 5 foot tall person, 5.5, 6.5, 5.75, whatever, some numbers. Does that make sense? But these are all in feet. Does that understand? All right, let's do the same exact thing we did before. Let's calculate the average. Let's find the difference between this and the average. Let's square all those things up, divide by however many things there are, -1, and then do square root, and we'll get the sample standard deviation. So this is equal to the average of this stuff. We get this number. Does that make sense? This is going to be equal to this number minus this number. I'm just going to put a $sign right here so that it doesn't change it. And then it just fills in the rest of this crap for me. Does everybody see that? Let's write this out almost the exact same way. Let's say this is equal to, no, let's not. Let's just do what I just did before. All right, so then we get this, right? Now I need to add up all this crap. We get this. Then I need to take this number and divide it by n-1. What is n-1 here? One, two, three, 1, 2, 3, 1, 2, 3. What? This is $11.
oh.
Divide by 10. Is that correct? But you still need to do square root. So I'm just going to do that now too. All right, so we get this thing. Does everybody see that? Note there is a function built into all these programs. which of course does this for you, gives me the same answer. Does everybody see that? Does that make sense? You got it? All right, now I'm going to take the exact same numbers, but I'm going to do it with inches. Does everybody understand? I mean, it's the same shit. Is that right? Whether I talk about how many inches or how many feet, the same heights. Is that correct? But obviously, if we talk about it with feet, the numbers are smaller. If you talk about it with inches, the numbers are going to be bigger. Is that right? 6 feet tall is 72 inches. Like, that's a lot better than 6. Is that right? All right, 5 feet is what? 60 inches, 70 duper. I don't feel like doing this. Let's just do this times 12. Yay. Huh? Because 1 foot is 12 inches.
Yeah, no.
This part here? Nope. Because you're squaring it. You understand? So it would have to be like 36 times all this. But you could just multiply by 36. All right, but I'm going to do it pretending like I don't know any of those things I just mentioned. All right, so this is our average here. Is that correct? Same exact thing. This is equal to quantity, this number minus this number here. Let's prevent this number from changing though. So I put a little dollar right there next to the 22 so the 22 doesn't change. Square this crap. That's this. Now, if I take every single one of these numbers and divide them by 36, it really should give me the same thing as this garbage over here, and it doesn't. Why not? Did I make a mistake? I think I did. Average. This number minus that number, quantity squared. Yeah, that's right. This number minus that number, quantity squared.
My brain is not working. Quite possible. Oh.
Moron. Unbelievable stuff I do incorrectly sometimes. Sorry. I don't know where the hell I came up with 6. There's 12 inches in a foot. It should be 12 squared. So if I divide all these by 144, it should give me the same answer. And of course it does. I don't know what kind of stupid thing I was just saying. You see all these numbers are the same numbers. So did I really need to really redo this way? Not exactly. Does that make sense? But I'm just pretending like we have no idea. Does that make sense? All right? Because that's how you'll see how this has any meaning or not. Okay? So sum, add all these things up, we get this. Does everybody see that? Then we got to take this, and then we got to divide this guy by 10. Is that correct? And minus 1, right? And then we need to also raise this to the power of 0.5 or take square root. Raise 0.5 is the same thing as square root. Does that make sense? So we get this number. Does everybody see that? I think so. I'm not sure about this part, honestly. So then this, we get that number. Does everybody see that? Now, this number is 144 times this number. Okay? But if you have two different data sets, and they start calculating the variation of this one, they start calculating the variation of this one. And someone starts telling you the variation of the first one's 0.678, the variation of the second one's 8.14 or something, right? I would say the second one's varying more. Is that correct? Is that right? Does that make sense? But the units in which I use are going to change whether or not how much the magnitude of that variation actually is. Is that right? Now we know that these are two sets of heights of the exact same people. It's not really varying more. It's the same damn heights. Is that correct? So what? Just depending on the way we choose to look at the number, then all of a sudden it's going to seem like it varies more? That wouldn't be good. Does that make sense what I'm saying? There has to be a way to better understand this. Does everybody understand what I'm saying? Does that make sense? And this to me is a very good example to talk about once you start discussing units, right? Because in this country, someone measures in meters or centimeters, and then in this country, someone measures in feet or inches. You should get the same answer, really. Is that right? Okay, so what gives, right? Well, it turns out if you take what they just told you to calculate, right? So they told you to calculate that the coefficient of variation is equal to the standard deviation divided by x bar. Does that make sense? Now, when they put numbers like this, you start taking two numbers, take a ratio of those two numbers, right? If the original one was in meters and this one was in meters, the meters would sort of cancel. Is that correct? This finds how many times x bar fits into s, right? That's what that finds. Is that correct? In other words, it's comparing the spread of the distribution to the average value, right? How many times does the average fit into the spread? Does that make sense? That can be thought of as a percentage. This out of that. Is that correct? What percentage of the standard deviation? What percentage of the mean is the standard deviation? Does that make sense? Does that make sense? Right, if I say like 3 out of 4, that means what percentage is 3 things out of 4? Is that correct? What percentage is the standard deviation out of the mean? What percentage is 3 out of 4 things, right?
That's not right.
75%. So then this thing here, S over X bar, right? Let's just calculate that. Let's see what we get. Does that make sense? So let me get this divided by this thing. And let's do it over here also. This divided by this thing. Bada boom. You see why they're saying a calculator? This number is referred to as a dimensionless number. Dimensionless means it really doesn't have any units. Dimensionless things are like ratios of things. Does that make sense? Because the units have to cancel. Does that make sense? Dimensionless things are always better than having units, because if one person does kilograms, the other person does pounds, like we're getting all these weird answers now. Does that make sense? You got me with this? Okay, so this fixes this problem. Does that make sense? It's a nice thing though, okay? But for your exams and stuff like that, the only thing you have to know is that the coefficient of variation is equal to standard deviation divided by x bar. So you have to find standard deviation, you have to find x bar, and then you divide. Question? Remaining, I think 2. Right? We're going to get to some examples where we're going to start using this a lot, actually. So we're going to show you a little bit of what it's used for. But it's a good question, okay? Because this is not obvious at all. So let me say one example that hopefully motivates why we're going to do any of this crap for the next time, okay? So I always use this example about this football player, all right? I honestly don't watch football anymore ever since they changed the rules. All the hitting stuff I don't watch. People all stopped watching because of Black Lives Matter. and stuff like that. Like all these white people, they stop watching because they're like, oh, they're kneeling and they're doing this and stuff like that. I was like, honestly, I do understand where a lot of these white people are coming from because like I don't give a shit what a sports player has to say about politics. Like, don't tell me what LeBron wants about politics. I don't care what LeBron does or doesn't do about politics. But at the same time, there's this other guy from back in the day, a few of them. Kareem Abdul-Jabbar. I don't know if you ever heard of this guy. Muhammad Ali is another one. And Jim Brown was another one. These were like three of the best athletes of all time, honestly. Okay. And they were some of the first superstars who were black. Okay. Bill Russell also, but yeah, but the thing was he was around in like the good old white boy time, and he didn't really push a lot of this social stuff as much as some of the other guys. But so it depends on when this stuff happened, because these guys came up and they were big time in the 60s and 70s when all the civil rights stuff was going on. They naturally got involved, right? Okay, so now today these people are like super famous and they're civil rights activists, and you hear about them all the time and all that kind of thing. So people are all like, oh, well, we should have black athletes and sports players and stuff like that. They should be representing everybody and doing this. But I'm like, why do we have some guy who's never been to college and that's who we're all listening to? You know what I mean? Like, I don't want to listen to LeBron. Does that make sense what I'm saying? All right. So I can understand where these people are coming from, but honestly, most of them are just being racist, being stupid. Like you like football, watch football. You don't like football, don't watch football. But like to tell me that this is the reason why you're gonna stop watching football, like you're a freaking idiot. Okay. But fine. That's what these people said. All right. But there was some other stuff that was going on at the same time, right? I told you about these rule changes. After these rule changes occur, I didn't really like the game anymore. I didn't really want to watch anymore, right? Plus, also, my team sucks now. So that's probably the reason why. I'm a Jets fan.
Y'all got Aaron Rodgers.
Now this is the first year. Been a long time, my friend. Here, you want me to show you what I remember about this thing? Okay. They recruited. So like the coach I used to have was, I really used to be very big into football. Okay. I used to play football. I used to really be very big into football. Strong safety. But then listen, all I used to know is the only thing my job was to do was to hit the running back as hard as possible. Okay. And then my other job was to do kickoffs and hit them as hard as possible. That's all I used to do all day long. I was good at that though. But forgot what I was just saying. You got me sidetracked. Oh yeah. This is what I remember. This was the last time the Jets had a decent quarterback. Miami's the last good quarterback the Jets had, other than Brett Favre. Brett Favre only played there for 1 year, and then he was already done. But anyway, so the Jets kind of suck. But anyway, there was this guy, Richard Sherman.
The man, the myth, the legend, the athlete.
You know Richard Sherman?
I love Richard Sherman. He is very intelligent. He went to Stanford.
What do you know about Richard Sherman?
I know that he talks a lot of trash and he backs it up. And he's
not anymore, but back in the day he did. But
he played for San Francisco now.
He's old now. But what else do you know about him? What did he win in the NFL?
Won the
Super Bowl MVP. He was the MVP of the Super Bowl when he was with Seattle Seahawks. You know where he grew up? You know where he grew up?
Actually, I know.
Out in California.
Oh yeah, Compton.
Do you know? So he just said what college he went to.
Stanford.
Stanford. That's like one of the best, if not the best school in the country.
Yeah.
All right. How the hell did this guy get in? All right. So I teach at this private school. Every single one of these kids gets 1,600. All of them. Well, not all of them, but a lot of them. So many that there's enough that you could be like, that is a bunch of them getting 600, 1,600, perfect score. All right. They got 4.0 GPAs. Their parents make them do all this other stuff outside of school, right? But there's been one kid from my school who's gotten to Stanford in the last 6 years. 6 years. And I'm telling you, these kids are good. They deserve to get in, actually. Okay? How much work they do and how well they do on these exams, whatever, right? Everybody got me? Richard Sherman, one second, sorry. Richard Sherman did not get a 4.0, did not get a perfect score on his SATs. Not even close.
Was a hell of a good football player.
He's a hell of a good football player, but that was not the reason why he got into Stanford.
Why?
He got into Stanford because the dude's a genius also.
Yeah, he's very smart.
Right? Why is he a genius though? Because I don't remember the exact numbers, so I'm making up the numbers a little bit. All right. But let's say he got a 3.4 GPA in his high school. Now, I got a lot higher than that. Okay. My ass wasn't getting into Stanford. All right. But he played football also. Obviously, he was pretty damn good. Right. But that's still not the reason why he got into Stanford. The reason why he got into Stanford was because if you compare him to the other people that went to his school, he did so much better than them. It's not even funny. These white kids in this school over here, right? Great. If one of them gets a 4.0 and the other one gets, and he gets 1,600 or she or whatever, right? And next one gets a 4.0 and he gets 1,600. They didn't do that much better than the next guy. They both got it. Is that correct? Right? That doesn't show me that much. If everybody's getting 1,600, it's like, yeah, whatever. They're teaching them how to do it. You know what I mean? Does that make sense? Right? But what about this dude? He got a 3.4 GPA, and supposedly the next highest GPA in his whole school was like 2.7. That means nobody's even getting B's. And this dude's getting A's sometimes. That means his freaking teachers weren't teaching him. That means the kids around him wouldn't let him learn, right? That means nobody's going to school. You know what I'm saying? But Boyo managed to do it by himself. Yeah, that's special. That means he deserves to get in. Does that make sense? Do you get what I'm saying? So the thing is like, it matters how much better I do than other people, right? But it also matters how much variation there is in my group. Because if there's not that much variation in my group, but I did a shit ton better, right? Then I should look even better. Does that make sense what I'm saying? Did you get what I'm doing that? That's the reason why we want to think about standard deviation. Okay, let's just try and do one example and then we'll go, just because otherwise I'm going to finish this whole class. So all right, so this is part of the reason why they want us to discuss this whole standard deviation thing. They want you to understand what z-score is. Does that make sense? Does that make sense? All right, so z-score is this formula. X minus x bar divided by s. Does that make sense? Sometimes these are called measures of relative position, okay? So not only do I care about how much, so here's a kind of a way to think about why we're gonna waste some time, right? Did I give you the example before, like if you make $1 million, is that good or bad? Right? It's not really very helpful just to talk about the $1 million. You need to talk about the $1 million relative to something. Is that right? So what they're saying here is it's not really that helpful to know just how much more than I scored than the average. It's important to know how spread out the distribution is also, so we can see how many times that spread fits into that difference. Does that make sense? So it says the first measure of relative distance called z-score. Z-score takes the data item and calculates how many standard deviations away from the mean it is. If X is a data item with a sample mean of X bar and standard deviation S, z-score of X measures the number of standard deviations by which X differs from X bar. So the simplest thing that I always remember with this means the number of standard deviations away from the mean. Does that make sense? Does that make sense? Suppose that a distribution of 300 items has a mean of 125 and a standard deviation of 4. Find the z-score of the item X is equal to 131. So Z is equal to X minus X bar over S. You're not really ever going to find a formula that's simpler than this one. If you know how to subtract and divide, you're good. Does that make sense? Does that make sense? All right, so how would you do this? What would I write in the formula? $131 minus what? Over 4. The way I want you to do it though is I always want you to plug in the numbers that are always have to be given to you. They have to give you what the mean and the standard deviation are. Does that make sense? So read the question, put the mean in here, put the standard deviation in here. Does that make sense? And then there's always some value that we're interested in. That one goes over there. Does that make sense? So then we get 6 over 4. We get 3 over 2. This is 1.5 standard deviations away. Or it's about 1.5 standard deviations to the right of the mean. Does that make sense? Does that make sense, guys? So like if I plotted these numbers on a number line, 1 standard deviation away, right? Be like $1.29, right? Then we have to go half a standard deviation to get to there. Is that correct? Any questions? A radio station claims that the amount of television advertising per hour of broadcast time has an average of 15 minutes, a standard deviation of 1.5 minutes. You listen to the radio station for 1 hour at a randomly selected time and carefully observe that the amount of advertising time is equal to 5 minutes. Calculate the z-score for this amount of advertising time. Round your answer to 2 decimal places. Well, I want you to just use the formula. I was just explaining what it means. So how would I do it in this case? What do you say? Nope. Yep, because that says average. Does that make sense? Always go and look for the average of standard deviation first. Does that make sense? What's standard deviation? What's X? What's the value you're interested in? Five. He says that they observed that there was 5 minutes of advertising time. Is that correct? Does it make sense? So this is -10 over 1.5. It's the same thing as -10 over 1/10 of 15. -10 over 15 is -2/3 times 10 is -20 over 3. Again, I would just do this on my calculator though. You don't have to do it the way I'm doing it. This is going to give you -6 .666666666, whatever. Does that make sense? Sorry? There we go. So then this is 6 standard deviations, over 6 standard deviations less than the average number. That's pretty far away from the average. Does that make sense? Does that make sense?
It doesn't make sense because I need other things.
You know, every time I see those sixes, I start thinking about it also. Now you see why they're bothering with us? Because I have to see how much variation there is in the group, right? Because if like you're different by this much, and the stupid thing's varying like just a little bit, like that's a big difference then, right? But stupid things varying a lot. Like we talked about, like that business, and they you sell one thing, 10 things, one thing, 10 things, one thing, 10 things, right? Does that make sense? Right? If I turn around and I was like, well, would it be weird to get 5? Not really. You know what I mean? Would it be weird to get 10? Not really. I just told you 10 happens a lot. Would it be weird to get 20? Yes, because the stuff is generally spread from only from like 1 to 10. Does that make sense? In a calculus class, Jack scored 6 on a quiz for which the class mean and standard deviation were 4.3 and 1.9. Norm scored 7 on the quiz for which the class mean and standard deviation were 5.2 and 2.1. Relatively speaking, which student did better and why? Well, how are we going to compare? This is another good example with this thing. All right. So this is another way that I can start seeing. So like, let's say you got one school in one bad area and you got one school in some good area, right? You give them the same damn test. Well, they probably got different teachers. One area, parents probably aren't home as often. Kids aren't forced to do this stuff all the time, right? So you should get different grades. Is that correct? Right? But like, if I go to the bad school and you go to the good school, and I get a garbage score on my test compared to what you got, should I really be comparing my score to your score? No, I should be comparing my score to the kids at my school. You should be comparing your score to the kids at your school. Is that correct?
That's not what we. I absolutely.
Well, that's why you gotta learn statistics. Because most of these people don't know statistics, and that's their problem. Because if they did, they wouldn't do this stuff. Does that make sense?
Like, I want to start on online and no, like, you know, something one. Every time I was. It's literally all the time.
Most of those dudes don't even know statistics. They just know that that's what you have to know how to do. They might have known it at one point, but they don't know it.
You talking about the investors? You talking about?
I'm talking about the Sharks.
Mhm.
I can tell you the ones on there that know math and the ones that don't. I can tell you in 2 seconds who knows math. But it's just the thing is a lot of people like learn stuff just to make it a little bit, but they don't really get it. So then they don't use it and then they forget it. You know what I mean? Mark Cuban, he seems kind of smart. He seems like he would know what he's talking about. Mr. Wonderful, at one point, he probably knew all this stuff. I don't know if he knows it. I don't know if he knows statistics anymore. He definitely learned it at one point. You know what I mean? The Hispanic guy, he definitely knows statistics. The white guys, like the older white guys, they don't know. And what's his name? Fat Farm or whatever his name is? Not Fat Farm. Damon? Damon, he don't know shit. No, he don't know shit. But yeah, don't get me wrong, that guy, he knows how to make money though. But you see, that guy, he knows who to put around him. You could just tell by the way he operates. Like he is not going to make a mistake. Like he will sit there and he will put the right person around him, and that's it. You know, once you got that much money, you don't need to know how to do this stuff anymore. You just got to get the right people, right? Because they can just bribe me to do it. I'll do it for them, right? They can buy me off in 2 seconds. You know what I'm saying? So like in a calculus class, Jack scored 6 on a quiz. So effectively what we need to do here is what you'll see, and this is a pretty good example in my opinion. Let's calculate the Z-score for Jack and the Z-score for Norm separately. Does that make sense? How would I calculate the Z-score for Jack? What would you say? So find the deviation from the mean and then just divide by the standard deviation. So what is it? Six is X minus what? Guys, for real, this is just reading. All you gotta do is read this first sentence. It says mean and standard deviation. It tells you right there. You can't read that? Yes, you can. 4.3 and then 1.9. Is that correct? Right? Was that hard? What's the other one gonna be? 7 minus 5.2 divided by 2.1. So now we gotta work these things out on our calculadora, right? So what we got? 6 minus 4.3 divided by 1.9. So we get 0.98947. 0.8947 approximately. Does that make sense? The other one, 7 minus 5.2 divided by 2.1. This is 0.85714 or whatever, approximately. Did I do these right? Yeah, that's about right. Does that make sense? What does this mean? Now, if they took the same test, obviously Norm got a better score. Is that correct? Norm got a 7 versus Jack getting a 6. Is that right? But yo, Jack went to a worse school. These kids got a 4.3 on average at Jack's school. These kids got a 5.2 at Norm's school. Or let's talk about both of them at the same school. One of them's in a gifted class and one of them's in the regular class. Does that make sense? Or honors, regular, whatever you want to call it. Does that make sense? You know what I mean? Well, if I'm in the regular class versus being in the honors class, I think the kids in the honors class generally do better. Is that correct? Does that make sense? But if we took the same damn test,
And the regular kids are outscoring.
well, not the regular kids are outscoring, but if we're taking the same test, right? And I get a particular score in my honors class or whatever, you should be comparing me to the kids in the honors class, right?
No, but that's not.
No, it is. When you do it correctly, it is. That's what they do. So the other thing is that this kid, compared to the people that took his test in his class, right? He got about 0.857 standard deviations greater than the mean. Does that make sense? Compared to the people in his class, compared to the distribution that he was involved with, he got about a little bit more, almost 1 standard deviation greater than the average. Does that make sense? This person also got about 1 standard deviation greater than the average. The only thing is this one got 0.8947 more than his average. This guy got 0.85714 more than this average. Jack did better, relatively, compared to his class. Does that make sense? And the thing that they usually do is they calculate this thing called a percentile, which we're going to talk about that also. But percentiles compare you to the other people in your distribution. What percentage of the people did I do better than? Does that make sense? If I tell you you got 100, but I tell you that 50% of the kids also got 100, so what? If I tell you you got an 80, but the next highest score was a 50, yo, you a goddamn genius. Does that make sense? Do you understand what I'm saying? So the problem is you got to compare to the group you're coming from. Does that make sense? How well did you do compared to your peers or your group, right? Then if we want to go and compare this somewhere else, we can. Another example with sports all the time that people always talk about with this is like different eras, right? Everybody always goes around as like Michael Jordan was the best basketball player of all time. Yo, if you compare his ass to LeBron, he looks like trash. Trash. No. But if you compare his statistics, and I go put his statistics down, and I show you LeBron statistics, and I show you Michael Jordan statistics, you will tell me LeBron is better. Okay, but I am telling you right now, Michael Jordan is better. Because the reason being is Michael Jordan blew out the people in his era, blew them out. There are players that score as much as LeBron now. There wasn't nobody scoring like Michael Jordan back then. You get what I'm saying?
Same thing with Curry.
There's nobody. He had 32 points a game. And the next highest player was like 29. And then there was 31 a different season. Next highest player was like 29. Then he had 29 points a season. And then the next highest player was 28. And then not only that, there was more defense back then. Dude used to play defense too. Dude was #1 defensive player in the game. Oh, by the way, never lost in the playoffs during the 90s or whatever. Now, when he first started in the 80s, he lost a bunch of times. But the thing is like during the 90s, never lost. Oh, I hate Michael Jordan. I hate Michael Jordan. I hate him. But the thing is, but it doesn't mean I can't say that dude wasn't the best ever. It was. He used to beat the shit out of my Knicks all the time. So no, but seriously, my point is though, it's not. So here's a better one to talk about. Okay. People always talk about how good sports players are, and oh, this one's good and that one's good, and Steph Curry and blah 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 blah. Right? You ever heard of this guy, Baby Ruth? Babe Ruth? You heard of Babe Ruth? Check this out. You want to see statistics. Here's his stats. Okay. By the way, the dude also used to pitch. He's an all-star pitcher also. Okay. 1927, I remember, was one of his best years, I think. So home runs, dude hit 60. Okay. Do you know what the next highest was that year? I think it was 30.
That's crazy.
It's 20 something. Okay.
That's crazy.
Do you know what I'm talking about? You know how crazy that is? That's like somebody coming out today and hitting 120 home runs.
That's crazy.
That's nuts. All right. Wayne Gretzky, this short little white or skinny little white nothing guy. Okay. Nothing. Like, dude, you could push him over. All right. Untouchable. Somebody just broke his goals record this year, but this record is untouchable. The one I'm about to show you.
You like Derek Jr.?
He stole my name, but yeah. No, I love Derek Jeter.
Yeah.
Steinbrenner, Stein Jeter. So no, I love Derek Jeter. Wayne Gretzky. Wayne Brady. Is Wayne Brady gonna have Slapovich? So then anyways, when you said Wayne Brady, I was like, should I say it? All right. So then the points. You see these points here? This is goals plus assists. Dude has over 200. Okay. Ovechkin. If I could spell the dude's name. Same website. Yo, this guy is like by far like the best player right now. Okay? I mean, not right now, but like over his career. Look at these points. He broke Wayne Gretzky's goal record. Okay? He just broke it this year. Just now. Okay? But look at this guy, though. Dude scored 87 goals in a season. All right, anyway, my point with this is that you need to compare people to their era. Does that make sense what I'm saying? Him compared to his era, probably the best player in any sport that's ever existed. Same thing with that Babe Ruth character. that make sense? Right? Steph Curry, when you compare how many 3-pointers he shot during his first couple of seasons, and you compare it to anybody before him, no comparison. None. Do you get what I'm saying? All right. But of course, his overall points were actually comparable. All right. You know, he scored 30 points a game. Well, a lot of people scored 30 points. But this type of stuff, almost impossible for it to come back. Will Chamberlain. Well, the only problem is Will Chamberlain couldn't win championships.
No, I would
He's only
say
won like one.
I'll say this. I you only did that once.
Now, there was another dude, Oscar Robertson. He played for the Milwaukee Bucks or something like that.
There you go.
You'd average a triple double for the entire season.
And Westbrook beat that already.
Yeah, we'll watch Westbrook.
You don't like Westbrook?
And I'm gonna drive and I'm gonna get fouled. That's what with it. So like the big O compared to Russell Westbrook. Anyway, so like the
What?
Westbrook sucks because he's got these things called turnovers. There's something that you should always look at statistics, assist to turnover ratio. So then if you're a guard, typically you look at assist to turnover ratio because you want to see how many times they dished it out compared to how many times they lost the ball. We know they're going to lose the ball, right? So the thing is his assists compared to his turnovers, not so great. And the thing is dude turns over the ball too much. Then on top of that, he misses too many shots. Then that's the reason why they dumped him on the Lakers. That's the reason why when he was on the Lakers that he didn't do so well. You know what I mean? Trust me, there's a reason why they couldn't get rid of his damn contract. All right. But anyway, hopefully this shows you a little example of why